Hello, my name is Virakaji. I'm from Section C, Professor Parker, and this is my Physics Lab 4 for oscillations. So the purpose of this lab is to observe the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. And this is the preview for my main result, and we see that the energy principle is relatively satisfied since the total energy is close to zero, although not exactly, which may be caused due to human error during the lab. So for introductions, we need to keep in mind Newton's second law, to calculate the net force, which will just summing all the forces, including the gravitational force and the spring force, and also the velocity update and the position update formulas, and also the energy principles, which are all these four equations shown here. This is for total change in energy, change in kinetic energy, and then for gravitational energy and spring energy. So part 1 is my tracker analysis. The system was the mass, the spring, and the earth, and the surroundings were nothing. So the sum of these three forces would have to be zero. These three energies would have to be zero. So these are the initial conditions given in the pre-lecture videos. The mass of the object is 0.402 kilograms, and this is the initial position, initial velocity, the length of the spring, and the constant. This is my glow script code, and in the top left corner we can see the initial conditions, the position, velocity, and the mass that I had to plug in, and also had to plug in the constants here, and put it in the L hat, and calculate the energies for the spring energy and the gravitational energy, and then summing them. And then here I can apply the velocity update and position update alongside calculating all the other energies to see if the energy principle is conserved. So this is my result of my tracker analysis. You can see in these two graphs from position over time, the model is the blue graph, and the experiment is the red graph. You can see that they are approximately the same graph. They're a little bit distorted, possibly due to human error. And this is the x position over time, and this is the y position over time. And you can see this graph in the bottom left corner. We are summing all of the energies, and we get that the delta E is approximately zero throughout the experiment. So what does it mean? Is the energy principle satisfied? This we can see according to this graph that yes. We can see that the change in energy is approximately zero, and as I said before, it is possibly due to human error that it might have deviated a little bit. So what does this mean? This is the calculated the average time for an oscillation in the x-axis and an average oscillation for the y-axis. I needed this oscillation in the y-axis to calculate the spring constant, which affected the spring force and the spring energy and the change in energy in total. So in conclusion, in this lab, I used the energy principle of Newton's second law to prove whether the energy principle is or is not applied to the experiment, and I analyzed the position of a spring mass system oscillating in 2 dimensions using tracker and calculated the change of various energy of the system.